Hello, my name is ZHIHU. I'm from the class 101. Yeah. Today I will introduce the factorization of the polynomial to. And the first part I will introduce the fundamental theorem of the algebra. We said if we have a function of fx equals a0x n plus a1x n minus 1 and n not equal to 0. Then we have the equation of the fx equals 0 has and only n roots in the complex domain. Heavy roots are counted as heavy. Moreover, the complex roots always occurs in pairs. A complex number that is a root that equation is also a root of its conjugate complex number. Now we can have an example. If f equal a plus b I is a root of the equation, then the x equal a minus bi is also a root of the equation. We have the proof of this. We already have the I squared equals the minus 1, and the function we have the same, and if we have the p equals m plus I is the root of this equation, we can substituting p into the original equation and organizing it into the equation with I as the unknown. Then we have say n I n plus say n minus 1 I n minus 1 add plus and say 1 I and say 0 equals the, and where the say I equal the is the function of which have the say n and say 0 say 1 dot and say n and m plot dot n. This is consistent of this function which is also actually value actual. And since the I square is the minus 1, we can organize the function and we can have this equation, and because it equal to 0, then we have C1 minus C3 add 35 minus C7 dot equals to 0, C0 minus C2 add C4 dot also equal to 0. And we can also substituting the p v equals to minus m minus n I into the original equation and organizing it into the equation with I as the unknown. Since the I squared equals to minus 1, we can also organize the equation, and we have this one. And we found that this one equals this one. We only to minus, so this one is also 0, and thus is m minus ni is also its root of this equation. And the second part, the factor of the theorem and the applicants. If the polynomials fa equals to 0, then the polynomial fx must contain the factorization x minus a. Thus, ax minus b is the factor of the fx. It is the same as the f b divided by a equals to 0. And the fundamental theorem of the algebra and the factorization theorem tell us the nth degrees polynomials are certain to be the factorizable in the complex domain. We have the example fx equals the a0 and x minus z1, x minus z2, and x minus zn, where the zi belongs to c. The third part is to factorization of the polynomials. Trial roots method. We can use this method to help us find the solution rapidly. It was the mention about that the nth degree polynomials are certain to factorize in the complex domain. Here we discuss the only case where the equation has the rational roots. For such polynomials, we use the trial roots methods. We have this function fx equals a0 xn plus the a1 xn minus 1 plus a2 xn2 plus until the an, and an not equal to 0 and a0 not equal to 0, and the an and a0 are all integer. If the x equal p divided by q is a rational number of the fx, p and q are multiple prime, and p belongs to n, q belongs to n, then the p must be the factors of the an, and the q must be the factor of the a0. Thus, in general integers, the numerator of the roots of a root is a factor of the constant term, and the denomination of the roots is the factor of the highest order term. So we can have the each example. First step, we can find out the possible root of this function f cube plus 3 minus 3x square minus 2 25 x at 21. Yeah, we can find the possible roots of the fx equals 0 because we have this theorem. Thus we can find the possible roots of this function. That's 1 and minus 1, 3 and minus 3, 7 and minus 7, and 21 and minus 21. So we can have the step 2, the verification of the substitution. We can find out one root of this equation, and we can find out f equal 1 is one root of this equation, and we can factorization. Yeah, we can use the factorization to fact this one, and we only to factor the x square and the 4x minus 21. And finally, we can have the fx equal the f minus 1 and the f minus 3 and the x plus 7. This is an example to use this theorem to find out the solution, of this question, and it is always be useful to solve this problem. And finally, thanks for listening.